Let's solve the exponential equation. 5 raised to the 2x plus 3 is equal to 3 raised to the x minus 1. In this problem, we're going to need to take a natural log of both sides. This is going to allow us to bring the exponents out front. When I do that, I do need to remember this set of parentheses and this one. And now we need to try to get x by itself. I don't like the way that looks. That was a 2x plus 3. Okay, so let's pause here for a minute. And let's just look at a related problem, but not really this, but just to help us out. This is 2x plus 3 times the natural log of 5. Well, the natural log of 5 is just some number. And so the natural log of 5 itself is not 2, but it's some number. So let's solve an easier equation that reminds me of this one. The natural log of 3 is just some number. So if the numbers were easier, right, 2 and 5. And again, not really, right? That's not what we have here. These are different equations. But let's just say we were asked to solve this one and go through the process and then apply it to this problem. Well, I think what we do first is distribute on both sides. And then we'd probably get everything with an x on one side. So we take 4x away from both sides. And I would have a 5x minus 4x minus 5. Let's get rid of the 5. Let's move it over here. And I know you're all screaming, hey, 5x minus 4x is equal to 1x, and I know x is 11. So doing that simpler problem, I hope is going to help us do this problem, because the natural log of 5 is just some number. So I want to do the same thing where I'm going to distribute it. I'm not going to find a decimal approximation for it at this point, because number one, I want to be able to find an exact answer. My instructions were to solve, not to approximate. So I'm going to need to do the same thing here for the natural log of 3. The other reason I want to avoid rounding here is even if I was asked to round to some number of decimal places, I want to round once. Because if I have to round more than once, I might compound the error. So I'm going to distribute. I have 2 times the natural log of 5 times x. I'm just going to put that in parentheses to make it look a little nicer. Plus 3 times the natural log of 5 equals the natural log of 3 times x minus the natural log of 3. And at this moment, I'm kind of looking at an equation like this, right? A number times x, well, a number times x plus a constant equals a number times x minus another constant. I need to get all the x's on one side together. Well, the last time I did a little subtraction. Okay, so I've taken that away from both sides, and that's going to get me to this step, where I have 3 times the natural log of 5 is equal to the natural log of 3 times x minus 2 times the natural log of 5 times x minus the natural log of 3. So now I'm really looking at an equation that looks like this. We can add the natural log of 3 to both sides. And I want to write what I get on a separate board. So let's just see if I can leave that much. All right, so 3 times the natural log of 5 plus the natural log of 3 equals the natural log of 3x minus 2 times the natural log of 5. And that's this moment. Because as ugly as this looks, it's just a number. It's not the number 11, but it is just a number. And now I have 2 things with an x in them. 2 things with an x in them that I need to combine, like terms. Well, 5 minus 4 is 1x. What I can do here is factor out an x. And this is the equivalent part to combining like terms, because now I have a number times x, just like this was 1 times x. All right, now to get x by itself, I just divide by that number. Divide both sides by that number, I should say. And so x is equal to 3 times the natural log of 5 plus the natural log of 3 all over the natural log of 3 minus 2 times the natural log of 5. And I think this is a nice final answer, but sometimes if you're doing the homework, they might ask you to simplify. So what I'm going to say is we could rewrite that 3 as an exponent. So that's natural log of 5 to the third. Well, 5 to the third is 125. Plus the natural log of 3. All over the natural log of 3 minus the natural log of 25, right? Bring that in as a 5 squared. Well, one more simplification. This is 2 logarithms being added together, so I can rewrite it as 1 natural log with 125 times 3, which I totally know is 375. That took a minute. All over the natural log of, and this difference would be 3 over 25. And there's my final answer.